Ladies and gentlemen, what's up? Here we go. We are moving on to section 5.3, and in this section we're going to talk about the last part of this foldable and how we actually go about solving quadratic equations. We've mastered factor and ZPP. We've now mastered quadratic formula. Beautiful. The massive, awesome, meticulous quadratic formula. Remember, factor and ZPP only works if you truly can factor the actual quadratic. Okay? Quadratic formula will always work no matter what. But here is the third method of proving, no, not proving, of proving, what am I talking about? Of solving quadratic equations. And it is called the square root method. Now, huge thing. So after you write square root method, flip up the part of the foldable and write a huge star next to this because this is extremely important. The only time that you're going to use the square root method is if there is one visible x. And I'm going to show you some examples of what that means. Factor ZPP, the only time you can use that is if you can actually factor it, and then of course go ZPP. Quadratic formula always works. Square root method only works when you have one visible x. Here is what that means. So let me go down to some examples. So you see, well, hold on. Bing. Okay. So you see some examples here. So which ones can you use the square root method? Well, where there is only one visible x is where you could do that. I'll circle the ones that it actually is true. This one right here, there's two visible x's. So no, I would not use the actual square root method. It would not work in that particular case. So no, wouldn't do it. This, oh look, there is one visible x, so the square root method would work. There's two, that would not work, the square root method. This would work because there's only one visible x. I know it's x squared, I'm not talking about that. That's why it's really kind of visible x in the terms of a quotation mark, because over here, oh, there is one visible x. So that one right there would be one that I'd use the square root method. There's one visible x. I'd use the square root method on that one. Oh, look, there's two x's right there. Nope, square root method would not work. Oh, look, there's one visible x, so the square root method would work. Oh, look, there's one visible x, so the square root method would work. Oh, look, there's two visible x's. Nope, wouldn't work. Oh, look, there's one visible x. I would use the square root method and it would work there. Oh, look, it's actually two square. Nope, there's two x's right there, so it wouldn't work. So again, the only time that the square root method will work is if you have one visible x in the actual equation. I don't care if it's in standard form or not, we're not talking about that. It is only if there's one visible x. Now, let's actually go figure out how in the world we do this, because let me do a quick recall for you. So write this down in the foldable too. When we're solving a simple equation like this, remember the goal is always to get x by itself. Always. So eventually you want x to be equal to something down here. That's what you're looking for. And of course, if you're going to solve this, yes, you would just add a 6. Yes, you would add a 6. You get 4x equals 48. Then yes, you would do this. Undo the multiplication by division, which would give you x equals 12. So your answer here for this particular equation would be x equals 12. It's the solution, meaning when I plug 12 back in, it works. However, here is now going to be the trick, guys. We're going to take this equation and we're going to put a goofy little 2 on top of it. So there isn't a ton that's changing, but now since I made it x squared, I'm now talking about a quadratic equation. So now we're talking a little bit different in how we're going to solve it, although I would tell you the goal still remains the same. We are going to get x by itself. Okay? So here we go. Let's go over and do this example. So 4x squared minus 6 equals 42. So I'm going to put some steps up here for you, really only 3 steps. And as I put the steps up, yes, you need to write them down, and we'll do this together. Step number 1, you have to isolate the actual quote-unquote thing that is squared. And I say thing because if you go back to these examples here, there's sometimes where the actual thing that's squared is, it's this whole entire thing right there. Hold on. It's this whole thing that's being squared. This whole thing that's being squared. There it's just an x. There it's just an x. There it's just an x. Here it's this entire thing 2x plus 5 that's being squared. So you have to first of all isolate that thing that's being squared. And I will highlight that for you in blue So this right here is the thing boop, boop, that I want to isolate first. That means I'm going back to my dog and cat example where I want to get rid of the cat first and the dog second. So this the negative 6, the minus 6, the subtraction of 6, I'm going to get rid of that first. By doing what, Mater? I'm going to add 6 to both sides. Exactly like we did over here in this example right here with my recall. So I add 6, so I get 4. And then I get x squared equals 48. So that means I'm still looking at getting this thing, step 1, by itself first. That's the thing that's squared. Beautiful. So what am I going to do? Same thing I did over here. Since I have 4 times the thing I want to get by itself, let's divide everything by 4 because I want to get rid of the multiplication of 4. Divide both sides by 4. That cancels out. So yay, I'm now left with x squared, the thing that I wanted to isolate first, equals 12. So that's step number 1. Now if we were just doing x equals 12, we'd be done, but we got some more work to do. So I've at least done that. Let me move this over. Okay, so I got x squared equals 12. That is step 1 where I have isolated the thing that is actually squared. Okay? Here's step number 2. As soon as we do that, as soon as that thing is isolated, now sometimes it's just not x, it actually might be something in parentheses, but that thing that I had to isolate, now I have to free it. I call it freeing it from jail, if you will. And how am I going to free it? I need to get this x freed from the square. How do I free it from the square? Well, algebraically, you do the inverse operation of squaring something, and that actually is square root. So I will take the square root of the left side, and if I'm going to do something on the left side, I do the same exact thing on the right side. But here is a huge, huge thing that you need to make sure that you start with this as well. As soon as you square root both sides, you've now created 2 scenarios. You've created a positive square root of 12 or a negative square root of 12. So anytime you do square root of both sides, you always do plus or minus. Now why are you square rooting it? Because here's what happens. The actual square and the square root cancel each other out. So I'm left with x. Beautiful. And then here I'm left with plus or minus the square root of 12. So that is beautiful. And now the last step is to do this. You have to simplify the square root, this thing right here, if at all possible. And that means I need to find 2 things, 2 factors of 12, where remember this first one is the highest perfect square that we can find. So I still have plus or minus. Can I do that? I sure can. That turns out to be this. Turns out to be a 4 and 3. So that means the square root of 4, 4 is perfect, so it's freed from jail. Out of jail it goes. It becomes a 2. The 3 is not perfect. It stays in jail. Wonderful. And I have the plus or minus over here. So what are my answers then, Mater? My answer happens to be this. It's x is positive 2 root 3, or the other scenario is minus a negative 2 root 3. This right here is how you're going to be writing your answer. That is the answer. There's 2 answers to it. It's either positive 2 root 3 or it's negative 2 root 3. Awesome. Let's do another example, shall we? So let's just make a simple one. I don't know. I'll make it an easy one. X squared minus 121 equals 0. Well, if I'm going to do this one, I need to isolate the thing that's squared. So I need to isolate this thing first. So I'll add 121 to both sides. So I get x squared equals 121. Step 2, now that this thing is isolated, I need to free that x by square rooting it. I do plus or minus because I'm square rooting both sides. That's right. So the square and the square root cancel out, so I'm left with x. Yay, it's free to do what I want any old time. So then I do plus or minus the square root of 121. Oh wait, 121 is a perfect square. So it's plus or minus 11. So my answer is x equals positive 11, or my answer is negative 11. Now, some people out there are going to say, why are you writing the positive 11? I don't need that. You could really just write x equals 11 or x equals negative 11. Of course, you need the negative. So there are your 2 answers to that one. Okay, let's do one more example. Whoops, I went too far. Let's go down. So we'll go down here and do one more example. So here's an example. 1/3 x squared plus 5 equals 32. The goal, again, let's get this thing right here that's squared by itself first. Let's isolate that. That's the thing that's squared. Therefore, I would subtract a 5 from both sides, which would give me 1/3 x squared equals 32 minus 5, which is 27. Okay. So then I need to get rid, again, I need to get this thing by itself first, my first goal, before I ultimately find my ultimate goal of getting x by itself. So I need to undo the 1/3. How do I do that? Well, I multiply both sides by 3, because that will clear this and make this disappear to a 1, really. So I get x squared, there you go, equals, so that's 60, 70, 81, when you take 27 times 3. And there we go. So I have x squared. Now my next step, beautiful. I square root both sides. I square root both sides. Hey, what am I forgetting? Mater, what are you forgetting? That's right, the plus or the minus. Ooh, so the square root and the square root cancel each other out. That means I'm left with x equals positive or negative square root of 81, which is positive or negative 9. So my answer is x equals 9 or x equals negative 9. There you go. So what's the scoop? Well, here's what we're going to do next. You're going to then have questions where you're going to be given something like 2 and then in parentheses x minus 2, then set that thing squared. Ooh, man, that's just really weird. Equals like 17. I'm completely making this up. But then in class, we're going to roll with this example and be able to master these types where we solve this thing for x. So there you go. Pumped up. We'll see you guys in class later.